Hi, welcome to the video on the Analytic Geometry series. So this time we're now focusing on aids on sketching the graph. So last time we're done with the domain and the range of Locus. We're done with the intercept. We're done with the symmetry. We're done with the asymptote. Actually, those are criteria in order for us to sketch the graph of a locus easily. So this time, we'll now be incorporating those past videos we've done in order for us to sketch the graph. Okay, so this time we'll be reviewing first what we've done with the past videos for aids in sketching the locus. So first is the domain and the range. So when we say domain and the range of locus, to solve for the domain, we have to solve for y in terms of x. And then the resulting expression with respect to x will get those values in a set of real numbers at which the resulting expression becomes defined. The range, on the other hand, is we'll have to solve for x in terms of y, and we'll have to look all the values of the resulting expression with respect to y at which it becomes defined. Now, the second is the intercept. So there are two intercepts with respect to the axis. So the first is the x-intercept and the second is the y-intercept. So when we say x-intercept, it is the value at which, it is the point at which y becomes 0. Y-intercept is a point at which x becomes 0. The next is the symmetry or symmetries. Okay, so when we say symmetries, there are three types. So I will have to check the graph at which it is symmetric with respect to x-axis, y-axis, or the origin. So when we say symmetric with respect to x-axis is when the existence of the additive inverse of y. When we say symmetric with respect to x-axis, so we'll have to check the existence of the additive inverse of x. And if it's symmetric with respect to the origin, it is the existence of the additive inverses x and y. So the last is the asymptote. So to solve for the asymptote, so let's check on the horizontal asymptote. So to solve for the asymptote, for the horizontal asymptote, so we'll have to solve for x in terms of the other variable. And if the resulting expression is a rational expression, then we'll have to look at which, when the denominator becomes 0, then that value is, let's say for example, you'll get a resulting expression, rational expression. So the value at which the resulting expression has a denominator 0 is at y equals k. So therefore y equals k is the line of the asymptote. And when we say we have to solve for the vertical asymptote, so we'll have to solve for y in terms of x, and then the process is still the same. That's it. Okay, let's take a look into this equation. 4x squared minus 8y plus 16 equals 0. So let's solve for the domain and range. So let's check first the domain. So solve for the domain, we'll have to solve for y in terms of x. So we'll get (8y) equals 4x squared plus 16, which implies y equals x squared plus 4 over 2. Now, whatever would be the value that we can input on x in here, the resulting expression will still be defined. Let's pick 0 from the set of real number. We can input 0 here, you'll get 4 over 2, you'll get 2. 2 is still a part of a real number system. Hence, whatever would be the value, the expression will still be defined, and so we cannot find a value on the set of real numbers at which this becomes undefined. Therefore, the set of real numbers, the entire set of real numbers satisfy this expression, and so the domain is the domain of 4x squared minus 8y plus 16 equals 0 is the set of real numbers. That's it. Okay, so let's check for the range here. So to solve for range, we have to solve for x in terms of y. So solving for x, we have 4x squared equals 8y minus 16. Divide both sides of the equation by 4, you'll get x squared equals 2y minus 4. And so x equals plus or minus the square root of 2y minus 4. So since the resulting expression is a radical expression, and so the index here is even, so we'll have to check that 2y should be greater than or equal to 0, otherwise we'll get it undefined. So therefore y is greater than or equal to 2. And hence, our range here of the expression is from 2 to positive infinity. So this is close because 2 is included here. That's it. Okay, so let's take a look into the intercept. So let's check first the x-intercept here. So if it's x-intercept, we'll have to assume y equals 0. So we'll have 4x squared equals negative 16, or x squared equals negative 4. So taking the square root of a negative number, it's not anymore a real number as what we reviewed last time. So therefore, it doesn't have x-intercept. So let's solve for y-intercept here. Let's assume this as 0, so you'll get 8y equals 16. And so y equals 2. Therefore, it doesn't have x-intercept, it has y-intercept as 0, 2. And that's it. Okay, this time we'll solve for the symmetries. So let's check if it's symmetric with respect to x-axis. So let's check the existence of the additive inverse of y. So if I replace this by negative y, you'll get 4x squared plus 8y plus 16 equals 0. This is not the same as the original equation, and so this is not symmetric with respect to x-axis. So none. Now let's check if it's symmetric with respect to y. So if I replace this by negative x rather, so you'll get 4 negative x squared plus 8y plus 16. You'll get 4x squared, should be negative 8y plus 16. Is still the same as the original one. Hence, by replacing negative x on x here, it will still get the original equation, implying that this is symmetric with respect to y-axis. Now let's check if it's symmetric with respect to origin. So let's simultaneously replace x by negative x and y by negative y. So if I replace this, you'll get 4 negative x squared minus 8 negative y plus 16 equals 0. You'll finally get 4x squared plus 8y plus 16 equals 0, which is not the same as the original one. Hence, this is not symmetric with respect to the origin. So the only axis at which this equation is symmetric to is for y-axis only. That's it. Okay, this time we'll solve for the asymptotes. So, the horizontal and the vertical asymptote. So again, for solving the horizontal asymptote, you'll have to solve for x in terms of the other variable and check if the resulting expression is rational expression. Otherwise, you cannot continue and you don't have a horizontal asymptote. Same with the vertical asymptote. You solve for y in terms of x. If I solve for x in terms of y, the resulting expression would be x equals plus or minus square root of 2y minus 4. The resulting expression doesn't have a denominator, hence you don't have a horizontal asymptote. Same with vertical asymptote. If I solve this, you'll get, implying that the resulting expression is, yes, it's a rational expression, however, it doesn't have a variable here. So you cannot find a value in the set of real numbers at which this denominator becomes 0 because it's already a constant value. Therefore, you don't have a vertical asymptote. That's it. Now, how do we sketch the graph of this? So let's have to check this here. So your range is starting from 2 to positive infinity, so therefore you don't expect your graph to be found here. So let's say this is your 2 here. This is your 0, 2. So you expect your graph starting from this level up there. You cannot find a graph found here, okay? Because your range is from 2 to positive infinity. But of course, you can expect that your graph should be expanded both right and left because it's a set of real numbers. Now let's plot the y-intercept here. So this is the y-intercept. You don't have the x-intercept, of course, because it can't be found here. This is symmetric with respect to y-axis. So technique is I have to find only a value of the graph. Points on this side, and let's duplicate this on the other side because it's symmetric. So it's mirroring on the other side. So I have to find a point only, like let's say 2 points. Okay, so in order for us to plot on this, I have to look for, because this is actually symmetric with respect to y-axis. Hence, whatever would be the points here, there is a point similar to from here, which is actually mirroring from this side. So I only have to get the values, points here, and then duplicate here. So let's pick a point at which x is, let's say, what's nice? Let's say at x equals 2. What if if the x equals 2 here? So if x equals 2, you'll get 16 minus 8y plus 16 equals 0, implying 8y equals 32, and so y equals 4. So therefore, you'll be able to find 2, 4 on the graph. So 2, 4 somewhere here. So since this is symmetric with respect to y-axis, you'll be able to find negative 2, 4 here. Remember, if it's symmetric with respect to y-axis, there is an existence of additive inverse. So additive inverse of 2 is negative 2. Therefore, you'll find a point as well, negative 2, 4. Okay. Another is, let's pick a point. What's nice? Let's say if I have to pick 1 instead. So if this is 1, 1 squared, 1 times 4, you'll get 4. I'm sorry, I have to shorten the value because my board is very small. But you can actually try that for other values larger than 4, 5, and so on. So here I use 1 because my board is very small. So if I use 1 here, this becomes 4 minus 8y plus 16 equals 0, implying that 8y equals 20, y equals, what's this? Divide by 4, I'll get 5. Divided by 4, I'll get 2. 5 over 2 or 2 and 1/2. Am I correct? This 4, 5 over 2. So that's 2 and 1/2. So that's somewhere here. So since this is symmetric with respect to y-axis, I also find somewhere here. So something like that. You can expand up there because the domain is actually the set of real numbers. So it's pretty obvious. I'm sorry. I don't have a perfect drawing. It's pretty obvious that the range is only starting from 2 to positive infinity because this is 2 here. So the range is starting from here going up there. That's it. Okay, so let's consider another example here. So the example is x squared minus xy plus 3 equals 0. So we will have to evaluate this in order for us to sketch the graph. So let's check for the domain. So for the domain, we'll have to solve for y in terms of x. So this is xy equals x squared plus 3, implying that y equals x squared plus 3 over x. So any values actually in the set of real numbers could satisfy this expression to become defined, except when x is 0. Because if x is 0, this becomes 0, and so the expression is undefined. Therefore, your domain of the equation is the set of real numbers except 0. That's it. Okay, so let's solve for the range. So to solve for the range here, let's solve for x in terms of y. So we can use quadratic formula here to solve for x. So you'll have a equals 1, b equals negative y, and your c is 3. So x equals minus b, so that's y, plus or minus the square root of b squared, so that becomes y squared minus 4. Your a is 1 and your c is 3. All over 2a. So this only matters here because this is the way we have to look into the expression that makes the entire expression defined. So this is y squared minus 12 should be greater than or equal to 0 because this is actually inside a radical sign and your index is even. So observe that I have y by special product formula. I have these. These are actually the factors. So this is actually greater than or equal to 0, which implies that this is either both positive or both negative. Hence, y should be greater than or equal to square root of 12, or y is less than or equal to negative square root of 12. That's it. And so our range here is, since this is greater than or equal to square root of 12, so starting from square root of 12 to positive infinity, union, starting from negative infinity to negative square root of 12. That's it. Okay, so let's solve for the x-intercept and the y-intercept. So for x-intercept, let's assume this is 0. So this is x squared equals negative 3. This becomes undefined, and hence you cannot solve for the value of x. Therefore, it doesn't have x-intercept. Now, let's solve for the y-intercept. So for y-intercept, if I assume x is 0, this becomes 0, this becomes 0, 3 is equal to 0 is undefined. Therefore, you also don't have y-intercept. Okay, to check for the symmetry, we'll have to check for first with symmetric with respect to x-axis, so for the existence of the inverse of y. So if this is negative y, this expression becomes positive. This is not anymore the same with the original equation, so therefore this is not symmetric with respect to x-axis. Existence of y symmetric with respect to y-axis. So we'll have to check for this existence of additive inverse of x. If this is negative x, this will x squared. Still the same. But if this is negative x, this becomes plus xy. So this is not the same with the equation. Therefore, it's not symmetric with respect to y-axis. So let's check if it's symmetric with respect to the origin. So the existence of both additive inverse of x and additive inverse of y. So negative x squared minus x minus negative x negative y plus 3 equals 0. This becomes x squared negative negative negative, so this is negative xy plus 3 equals 0. The same with the original equation, therefore this is symmetric with respect to the origin. So let's check for the asymptote. The horizontal asymptote. So for the horizontal asymptote, we have to solve for x in terms of y, and then the resulting expression should be a rational expression, and check for the denominator when that becomes 0. So horizontal asymptote, let's solve for x in terms of y. But when we solve for x earlier, it's minus it becomes y plus or minus square root of y squared minus 4ac, so that's minus 12 over 2a, so that becomes 2. It's constant, so whatever would be the value of this x, this will not change. Therefore, you don't have a horizontal asymptote. So let's solve for the vertical asymptote. So solving for y in terms of this. So you'll have x squared plus 3 over x. So this becomes 0 when x is 0, therefore x equals 0 is the vertical asymptote. So this is x equals 0. Okay, so let's plot the graph of this locus. We'll have xy plane here. Remember, the domain is all the set of real numbers except 0, so you cannot find a graph passing through this vertical axis. Now the range is starting from square root of 12 to positive infinity. Square root of 12 is approximately, that's 3.5. So starting from here, so let's make a boundary here. That's 1, 2, 3, 4. So let's start a boundary here. You cannot find your graph in here. It's only somewhere there or somewhere here, something like that. And you don't have x-intercept, of course, because you cannot touch in this region. You don't have y-intercept, of course, because you cannot touch in this region. This is not symmetric with respect to x-axis. This is not symmetric with respect to y-axis, but it's symmetric with respect to origin. Hence, if you can find a points here, the mirror should be here. If you can find a points here, the mirror should be here. So let's check. The horizontal asymptote, you don't have horizontal asymptote because you don't have a graph here. But a vertical asymptote is at 0. Okay, that's it. Now, let's try to pick, let's say this is 1, 2, 3, 4, 5, 2, 3, 4, 5. Let's try to pick a value at when x equals 1. When x equals 1 is 1 minus y plus 3 equals 4. implying your y equals 4. So you have a point 1, 1, 4. So from 1, you'll have a point here. So since you have a point here, technically you have a point here because it's symmetric with respect to the origin. Let's find a point x equals 2. When x equals 2, this becomes 4. This becomes minus 2y plus 3. This becomes 5 equals 2y. So y equals 2 and 1/2. So 2 and 1/2. So that's probably, is that so? I'm sorry, it should be 7. Oh my god. This is 7, so it should be 3 and 1/2. So that's here. So it touched the boundary. So what happened? So somewhere here. So remember, even if I don't have to find the rest of the points here, I shall know because this is asymptotic with respect to x-axis. So I'm sorry, with respect to x equals 0, so it's y-axis, so something like that. It never touched the y-axis, something like that, and something like that. Okay. Now let's check the other points here. When x is negative 1, this becomes 1 minus plus y equals plus 3 equals 0, so y equals negative 4. So negative 1, y equals negative 4. It's still the same. So therefore, your final graph is this. That's it. Okay, so let's consider another example here. You have x squared plus y squared minus 9 equals 0. So let's check for the domain first. So solve for y in terms of x. You'll have, which implies y equals plus or minus square root of 9 minus x squared. So this is under the radical sign, so this, and your index is even, so this should be greater than or equal to 0. Or you can have x squared minus 9 is less than or equal to 0, which implies x minus 9 and x minus 3 and x plus 3 is less than or equal to 0. So this is actually intersection, so you'll have the domain is from negative, because this should be, this is either positive or negative or and positive. So you'll have negative 3 to positive infinity inclusive intersection negative infinity to 3, which implies the interval is negative 3 to 3. Let's try to take a look. Let's pick up 4 here, which does not belong to this interval. If apply 4 here, so this becomes 16, so you'll get negative 7, which is undefined. If you pick 0, which is in this interval, 0 here, so this becomes positive, and so this is defined. Therefore, your domain is negative 3, 3. That's it. Now let's solve for the range. So for range, let's have x squared equals 9 minus y squared, which implies x equals plus or minus square root of 9 minus y squared. So this is technically the same earlier, the same with what we've done earlier. So 9y minus y squared greater than or equal to 0, implying y squared minus 9 is less than or equal to 0. And so we're done with this earlier. The range is from -3 to 3. So the same here. That's it. Now let's check for the intercept. So the x and y intercept. So let's start first with the x-intercept. So for x-intercept, let's assume y equals 0. So x squared equals y equals 9, implying x equals plus or minus 3. So your x-intercept is 3, 0, and -3, 0. So let's check for y-intercept. So let's assume this becomes 0. So your y squared equals 9, implying y equals plus or minus 3. And so your y-intercept is 0, 3, and 0, -3. So you'll have 3, 0, and -3, 0. This is 0, 3, 0, -3. That's it. Is this symmetric with respect to x-axis? So let's check the existence of -y. If I substitute this by -y, this still -y squared becomes y squared. So it's still the same with the original, therefore it's symmetric with respect to x-axis. Symmetric with respect to y-axis, so existence of -x. -x, it's still x squared, so it's symmetric with respect to y-axis. Now, if I substitute this by -x, -y, it still be the same, so it's symmetric with respect to the origin. So let's check for the horizontal asymptote. So, solving for x in terms of y, remember that when we solve for x in terms of y, we have plus or minus square root of 9 minus y squared. And if we solve for y in terms of x, we have plus or minus square root of 9 minus x squared. Both of these equations don't have denominator, and so we don't have asymptotes. We don't have the vertical and the horizontal asymptotes. That's it. So to plot on these, let's just remember that the domain is only from -3 to 3. So 1, 2, 3, this is the boundary. 1, 2, 3, this is the boundary. The range is -3 to -3 to 3. So this is the boundary. 1, 2, 3. This is the boundary. Therefore, you can only find a graph here in this region. Now the intercept, for the x-intercept, you have 3 and -3. The y-intercept, you have 3 and -3. Symmetric with respect to x-axis, with respect to y-axis, and with respect to the origin. So if I do something here, this will reflect here. If I do and this will reflect here. Okay, if I do something here, this will reflect here because it's symmetric with respect to the origin. And so it will be the same as here because it's symmetric with respect to y-axis. It will be the same as here because it's symmetric with respect to the x-axis. So I only have to find values here. So let's check. What happened? What value is this? This is x equals 2. So when x equals 2, this becomes 4 plus y squared minus 9 equals 0, implying y squared equals 5. And so y equals plus or minus square root of 5. So probably square root of 5 is somewhere here. If I substitute this by 1, let's check when this is 1. If I substitute this by 1, this becomes 1 plus y squared minus 9 equals 0. So you'll have y squared equals 8. implying that y equals square root of 8 here. So that's probably somewhere here. So if you sketch here, it's something like this. Now this is symmetric with respect to y-axis, so it's something like that. Now this is symmetric with respect to the x-axis, so it should be like this. And so like that. I'm sorry, my drawing is not perfect, but technically it's actually a circle. Take a look into this, what we've done with the previous video. This is actually an equation of a circle with center at 0, 0, and the radius of 3. That's it. So if you have questions, clarifications, you can comment down there. Okay, so here's another example. 3y squared minus xy plus 2 equals 0. So I'm not gonna solve on this. I'm not gonna sketch the graph on this. But I want you to solve for the domain, the range, the intercepts, the symmetries, and the asymptotes, and you can comment down there. Or you can finally sketch the graph on these. And if you have question, you can comment down there, or you can contact me. Okay, so we're done with sketching the locus. So we're done with the domain, the range, the intercept, the asymptotes, and the symmetries. If you have questions, comments, you can comment down there. And for those who haven't subscribed yet, you may now subscribe on the subscribe button below. Thank you so much for listening, and God bless.